Hi folks, welcome to an introduction to conditional probability. Today we're going to take a look at how conditional probability might play a role in our lives. So some of you might recognize this image. It was used as the image for coronavirus disease 2019, better known as COVID-19. And so on March 11th, 2020, the World Health Organization, better known as WHO, declared COVID-19 a global pandemic, as these number of cases went beyond 121,000. Now, some of you may know it went well beyond 121,000, but that was the day they declared it a global pandemic. And so what they were searching for across the world is things that could test the disease. So now many of us, we might think that testing is sitting in a room where a teacher awaits to look at our output, but this form of testing plays a much larger role in our lives. So for COVID-19 testing, one of the original tests had doctors and other health professionals collect an upper respiratory nasopharyngeal swab. Okay, now when I first heard nasopharyngeal, uh, the mere sight of the word made me grimace. And in order to get a better image, here's the actual meaning, a visual for the actual meaning behind the word. So, and thank you to Raymond Specking for this image that it will now stick in my mind when it comes to COVID-19 testing. But so let's just say the health professionals tickle the back of our nasal passages with a long version of a Q-tip to collect the sample. Okay, so I know very scientific there. But here's where the magic happened. The sample was sent to a lab, okay, and they went through this lengthy process of mixing special chemicals with the RNA from the sample and analyze these combinations through a machine that detects if the sample is positive or negative for COVID-19. Okay, combine this process along with the backlog of samples. Think about how many people are sending in samples, and we have a small number of labs that can test them due to the rise of individuals being tested. So we had a whole number of people being tested. We found the wait period to be 4 to 7 days. So what people wanted to see is there a way to fix this? Can we find a test that can be processed more quickly? So one example actually looked at people's blood for antibodies produced by the immune system to fight the virus, and it took less than an hour to process. So basically a prick of a finger and go ahead about your business. And so as a matter of fact, in real life, on March 25th, British officials ordered more than 4 million of these tests, according to a Bloomberg article, which I'll save the name of the article just so it doesn't give away the story here. But so it gives you an idea that, hey, we're looking for faster tests. We want to get this out there because 4 to 7 days and you could be spreading COVID-19 in that meantime. Well, we want to try and find that information as quickly as possible and have people make sure they're self-quarantining in those cases. So this solves our problem, right? Well, not so fast. When it comes to like diagnostic testing, excuse me, there's two things we have to be concerned with, and they're false negatives and false positives. So the false negative is the case where a person has tested negative, but the person actually would have COVID-19 or contracted the disease in this case. And so this is a concern to both the individual and the public at large, right? Because they'll be spreading it around to the public. In the case of COVID-19, it can. That's why we had the social distancing going on. It can spread from person to person. So it's a risk to the public and it's a risk to the individual, obviously not knowing that they have COVID-19 and then thinking that they don't. Thinking that they don't have COVID-19 and actually spreading it around. So the other case is the false positive. Okay, so the false positive is more scary for the individual as they'd receive a positive test result, but they don't have COVID-19. Okay, so you could kind of see that's going to take more of an emotional toll, but the real danger one that we're going to focus on here is a false negative. So keeping that in mind, what comes to the rescue? Well, just like vanilla ice knowing how to solve problems, we can call upon the concept known as conditional probability to solve our problems. If we have two events, E and F, where the probability of F does not equal 0, then the conditional probability of the event E occurring, given the event F has already occurred, and then we have this fancy notation, which we call the probability of E given F for short, is given by the probability of E and F both occurring divided by the probability of the event F occurring. So now, relating this back to the false negatives we mentioned before, the probability of a false negative is just the conditional probability. Okay, so it's the conditional probability that a person contracted COVID-19 given they tested negative. So in our formula, if we wanted to use this in the formula format, this is the probability the person contracted COVID-19 and tested negative. So both of those happening at the same time, divided by the probability they tested negative. So now I'm going to give a fair warning for this example. The percentages are completely fictional. I'm making this up just to try and reiterate how we could use this. Obviously, they're going to get different data, and I didn't have access to the data, so sorry, folks. This is the best I could do in terms of just coming up with numbers to try and illustrate what happened. Okay, so the test taking 4 to 7 days to be completed and produced a negative result for COVID-19 59.8% of the time. Meanwhile, we'll say the percentage of people with a negative test result for COVID-19 and having contracted COVID-19 sits at 1.2%. Okay, so now we can run through our calculations, noticing that the probability of a person contracted COVID-19 and tested negative, which I'll shorthand that with contracted COVID-19 for CC and then tested negative for test 1, T1N is what we'll do from here on out. So that is 1.2%, or if I write it as a decimal, 0.012. Okay, and then the probability of a negative test is 59.8%, or I can write that as a decimal, 0.598. So we plug these into our formula, and notice we get the probability of a false negative, essentially, with test 1 is 0.02. Okay, so let's take a look at a scenario for test 2. So the test taking less than an hour to be completed, so this was test 2, produced a negative result for COVID-19 10.4% of the time. And meanwhile, the percentage of people with a negative test result for COVID-19 and having contracted the disease, COVID-19, sits at 0.9%. So I want to bring this to your attention. 0.9% for the both contracting COVID-19 and getting a negative test is actually less than the 1.2% that we saw in the previous example. Okay, but let's see what happens when we look at this number of false negatives. Okay, so just like we did before, we can use our previous calculation method with just this probability of contracting COVID-19 and test 2 being negative is 0.9% or 0.009. So, and if we divide that by the probability of test 2 being negative, which is 10.4%, which we could write as 0.104, notice we end up getting 0.087. And now let's compare our results. So, when comparing the results, test 1 has its probability of a false negative being 0.02 or 200ths or 2%, whichever way you want to look at it. While test 2 has the probability of a false negative being 0.087. Okay, so that's 8.7%. So now the question is the saved time in receiving test results worth the higher probability of a false negative? Well, in this case, I would say no, because when you look at about with this, the number of tests out there, you're talking millions of people, right? And it's 4 times more likely you'll have people walking around thinking that they're negative, but they actually have the disease. So that's more people that could spread the disease, and you're talking for every person, I believe at the time they were saying this and running the study, it was 3 times, for every person, 3 people could contract it, is what would happen if you weren't practicing social distancing. So obviously, that's a concern for everyone and the public at large, so no. Now, as I said, the numbers were fictional before, but let's actually see what happened in real life. Well, the UK found out that this test that they purchased, remember I mentioned they purchased 4 million of these antibody tests. Well, they actually had to go back and try and recover costs because it wasn't an accurate test. It wasn't accurate enough for them to find whether COVID-19 was present or not. So keep that in mind. There's cost associated with this. Now, conditional probability doesn't just play a role for COVID-19. It's all over the place. If you're actually interested in, it doesn't just belong to the medical field in terms of a lot of these sorts of issues. But an interesting book on false negatives that you might want to check out is How Doctors Think by Jerome Groopman. If you get the time, check it out. It's a good time in terms of learning about just different ways conditional probability and false negatives can come into play.